Now, when they rotate, they stop. This is called the terminal side. You drop your triangle. Remember we talked about your bow tie, your reference angles. The reference angles make a bow tie. They drop down to the x-axis, not the y. When I was teaching Algebra 1, I would always tell my kids, picture me with a big red bow tie on. They gotta look like a bow tie. They can't look like this. That's according to the y-axis. Not happening. That doesn't even work well. But here's your bow tie, up and down to the x-axis. This was the x, this was the y. On your unit circle, your cosine is your x, your sine is your y. The only one that will give you trouble is your tangent. And remember, we talked about the denominators have to be the same because they're both over the same hypotenuse. So it will just condense down. Knock out your 17, the denominator, whatever it happens to be, and condense your fraction down. The reciprocals are nice because you just flip everything over. They're already in fractions. Good? Was this okay? I know this is a little redundant, but I think what happens is you kind of get used to doing this. Also, if it helps you, just make a box. I find the box very helpful. And r is equal to 1. And you never have to look back to your coordinates. You never have to look back to your triangle. You pull all your pieces off of that. Make a nice little box. X, Y, R. And then we don't have to do, all students take calculus, all students take chemistry, whatever, how you remembered it. You don't have to worry about that. You also label your quadrants in the way that you rotate your angles. Did you ever ask, like when you were in 8th grade or when you first learned trig, why we label our quadrants from here? Why they're labeled this way? Because this is where your angles rotate. So that is the first quadrant you enter. But nobody tells you that when you're in 8th grade. They just label your quadrants like this, and everybody labels them the wrong way because everybody reads left to right and they start with the left-hand side one. But you label them with this starting at 1 because this is where your angle opens up into. If it rotates clockwise, counterclockwise. Okay? Alright, so you had a few of these, and I put one in different quadrants. And again, they all make a reference angle to the bow tie. They all come to the bow tie. They're all a reflection out of your first quadrant, so they have to be the same exact triangle. The only thing that's going to change is because it's on your xy axis, x will be negative, and anything that's to the left here, y will be negative, and anything that's below the axis there. And these are your special triangles. These are your special rays. They're called your triples. They're triples because they work out into Pythagorean's theorem perfectly. There's no radicals left in here. 3, 4, 5, 5, 12, 13, the one with the 17, 18, whatever that one was. These are your triples. 3, 4, 5 is the one you probably remember the most. Okay. The ones I was really concerned about were these guys. These are your special right triangles. And you're going to rotate them around. Okay, again, they start here and they open up into a circle like this. If this is your denominator, 4 pi over 4, 8 pi over 4. Figure out where the angle falls. They all work off the same reference triangle. So we're in quadrant 1, label your triangle. I put it on a unit circle. You do not have to use a unit circle. If you use yours, 1, 1, radical 2. They're all ratios. I rationalized mine because I put it on a unit circle. But you don't have to do it that way. So this would be 1 over radical 2, 1 over radical 2, and you'd be fine. And this is radical 2, radical 2. One over radical 2. This would be 1, 1, 1, radical 2. What? Number 25, it rotated down one here. A negative would bring you, you have to come down clockwise. It would bring you all the way back to that same triangle. You would have the same values as you had in the first one. They all start at your positive x-axis. The negatives just rotate clockwise. You would think it would be the opposite way, but it's counterclockwise and positive, clockwise and negative. 2 pi over 3, 3 pi over 3, 6 pi over 3. 2 pi is 1 less. So drop your triangle, and if you make it the other way, that is absolutely fine. This is a 60-degree, radical 3, 2, 1. X is equal to negative 1, y is equal to radical 3, and r is equal to 2. I don't know if you did these on a unit circle. I think my directions failed to say unit circle. And this one also, because you're rotating negative, there's your 3, it's coming up, there's your 6, so it's got to be 1 less than that. Put you in quadrant 1. It's got to have the same pieces as 27 did. Same reference angle, no matter what quadrant you land in. And the last one, negative pi over 6, that one had a 30-degree reference angle. And you can label it any way you like. X is equal to radical 3, y is equal to negative 1, and r is equal to 2. The radius is always positive. Always positive. No matter what quadrant you go, the radius is a measure from the center to the end of the circle. Technically, this is where your angle opens up along the circle. That's the terminating side. It opens up like this, or in a negative angle, it will open up like this. And that's your do you remember learning coterminal angles? We're going to take a look at those today. They land at the same terminal side. Like if this is your negative 30, your negative pi over 6, your coterminal positive angle will start here and terminate there. That'll be your 11 pi over 6. And to make a complete circle. Okay. So today we're going to and just get those done. Your reference angles, they're the little acute angles that are formed by your bow tie, by your terminal side. These are these reference angles that are formed here. Anything over here, 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 they're acute angles that are formed. When your angle opens up here, it forms a reference angle from the terminal side to the x-axis. Never the y-axis. It has to look like a bow tie. So if we're looking for your reference angle here, again, try to work these in radians. Try not to convert them. Take your denominator. This has to be pi. This has to be 2 pi. So that has to have the same numerator and denominator to cancel out the pi. Whatever that denominator is. Over here, it's doubled. So 8 pi over 4. So if I'm starting here and I'm opening up counterclockwise, what quadrant would I find 5 pi over 4? Third. So it's coming all the way around to here. Here's my terminal side. I bring a triangle up to the x-axis. And right here is my reference angle. And how many times does 4 go into 180? 45. That's a 45 degrees reference angle. So however you want to label this, 1, 1, radical 2. Start like that. X in this quadrant is positive or negative? Negative. Y in this quadrant is positive or negative? Negative. And your radius is always positive. From here, can you give me the sine, the cosine, the tangent, and all the reciprocals? So your reference angle is the angle that's formed when you drop your triangle to the x-axis. It's an acute angle. It is the same triangle that came in this quadrant, this quadrant, this quadrant. It's just rotated or reflected, if you will. Same triangle. We can do this in degrees. So if I'm looking from here, I know this is 0, this is 180. What quadrant do I find 203? In the third quadrant. So again, I open up here. Here's my terminal side. I drop a triangle to the x-axis. I have to make a bow tie. This guy in here is my reference angle. Now, work the diagram. Don't memorize the rules. As you come across, you went past 180 and you stopped at 203. That angle is between here and here. So how do you find that reference angle? I want you to look at the diagram. We came past the 180 and we stopped at 203. Subtract 203 minus 180. I came past the 180, right? To 203. So how far past the 180 did I come? Subtract it. So this reference angle is 17 degrees. If I don't have a special triangle for that, that's okay. But the reference angle itself is 17 degrees. Yep, it is 23 degrees. What was I thinking? 23 degrees. Thank you, Thomas. Thank you. Sometimes I'm a little dyslexic. Okay, so no matter what quadrant you are in, it will behave the exact same way. Okay, where would I find an angle 295? This is 0, 180, 360. And what quadrant? 4. I come all the way around. Here's my terminal side. I drop a triangle to the x-axis. Now I want you to think about this. This is 295 up to here. How far do I need to go to hit 360? 360 minus 295, and what did you say, 65? Everybody see where he's getting that from? Use your grid. Don't try to memorize when do I subtract from 180, when do I subtract from 360. It makes more sense if you use this grid. How about an angle of 145? What quadrant is 145? Second. I come all the way over here. Here's my terminal side. This is 145. I drop my triangle. This guy over here is 180. What's my reference angle? 35. Everybody see it? Don't try to memorize when do I subtract from 180, when do I subtract from 360, when do I add to 180. Use your graph. Now, coterminal angles share the same terminal side. So let's just do one in degrees here. If I have an angle of 120 degrees, what quadrant am I in for 120 degrees? Second. I start here. I open up. This is my terminal side. This is 120 degrees. Here's my 180. What's my reference angle? 60. My reference angle is 60. Now, I want a coterminal angle. I want an angle that stops at that side. I have two ways to go. I could come from the positive side. Well, I can't use that one because that is 120. But I can come all the way back around another 360 degrees around plus 120. And I could be 480. 480 would have the same terminating side. Would it not? You start at your 120 and go all the way around 360. Now I also can have a negative coterminal angle. I could start from here and come around and meet it. Now, without memorizing any rules, if I start here and my green one comes here and the black one comes here, I made a full circle, did I not? So how would I find, if this was 120, how did I find how many degrees this one went? 360 minus 120. So therefore, 240 degrees from the negative side. See your coterminal angles? You'll have a coterminal negative, you'll have a coterminal positive. And I can have many of these because I have to keep doing this would be every plus every negative of 360. And this one would be plus every 360. Keep adding 360, keep adding 360. You'll keep doing my negative 360 from there. They will keep terminating at the same side. Doesn't matter what quadrant you're in, it works the same way. Okay? Now, reciprocal functions. Reciprocal functions again. It's easier if you work your y, your x's. If your sine is y over r, your reciprocal is r over y, because it's 1 over your cosecant, and your cosecant is 1 over your sine. This is the point you probably remember. You're going to flip them over. It's easier when we do x and y's and r's to just flip the x and the y and the r, like you did with the first part of your homework. You took the fraction and you flipped it over. No one makes a complicated, complex fraction and then have to flip it. If your cosine is x over r, your reciprocal is r over x. If your tangent is y over x, then your x over y. And it works the same way for these guys. These we use more in terms of, do you remember when you had to do the proofs? If you had a statement and you had to bring it down to another statement, those are when we usually use those. But we don't do those in precalc. Your quotient identities. Here's some more identities that you learned back in Algebra 2. Your tangent, again, is your sine over cosine. This is always helpful. That's always helpful to remember. And do you guys remember this one? Sine squared plus cosine squared equals 1. Oh, well, here's an easy way to remember this. Here's your unit circle. Your radius is what on your unit circle? 1. Boys, your radius is 1. This is the point xy. This is the measure of the x. This is the measure of the y. Right triangle, Pythagorean theorem. X squared plus y squared equals 1. Is it okay if I turn this around? Does it matter what order I put them in when I add? No. Now, on your unit circle, because your radius is 1, your cosine is your x, your sine is your y. So it fits right into your Pythagorean identity. That's why it's called the Pythagorean identity. That is the only one you have to remember. The only one. We can get these two from this one. So when you see the something squared plus something squared equals 1, don't you kind of think a squared plus b squared equals c squared? When you see something squared, and 1, this is your unit circle. It's just on the unit circle. So it's Pythagorean's theorem applied to your trig functions. Now, to get to the rest of these guys, watch how easy this is. You don't have to memorize these. You just have to kind of learn how to identify them, and I'll show you an easy way in a second. If I divide everybody by sine squared, I have an equation. I divide everybody by sine squared. Sine squared over sine squared is 1. Cosine over, cosine over sine is cotangent. If they're both squared, there's my cotangent squared. 1 over sine, cosecant squared. So you can find them yourself. You don't have to memorize that. And on the flip side of this, divide everybody by cosine squared instead. Sine over cosine, tangent. Cosine over cosine, 1. 1 over cosine, secant. Right? An easy way to get to them. You don't have to memorize these. You just kind of have to learn how to identify them, how to recognize them more. Okay. Now, again, on your non-unit circle, what quadrant would this point be in? So 12, negative 5. Works perfect. Here I am. I came around. I terminated on that side. So my angle came through. I dropped the triangle. This was 12, negative 5. X, Y. There's my X. There's my Y. How do I find my R? Pythagorean theorem. So 12, Y is negative 5. Do Pythagorean theorem. This is one of your triples. Try not to use the negatives, because what happens when you put it in your calculator with a negative, if you don't put it in parentheses, then you didn't square the negative and get a positive. So be careful of that. And from here, you can use any of your triangles. Any of your functions, and go through the x, y, and the r with your functions. They will all reduce down just like you did in your homework. Just like your homework did. And then these guys, just one other thing, and then I'll give you the homework. If I gave you a cosine, and I said find all 6 values, if I give you the positive, well, right now we'll assume it's in quadrant 1. Remember, x over r, 5 over 7. How do I find out the missing piece? Pythagorean theorem. 7 squared equals 5 squared plus y squared. 49. And you're going to have to leave these in radical forms if you can't solve them. I'm not past today. When you take the square root, guys, one thing, just leave it in reduced radical form. So this is 4 times 6, so 2 radical 6. And then you can find all your trig functions with that. Okay? All right, let me give you your homework.